communication.
All right, can you hear me? Hey, how's everyone doing? Awesome, sounds great. So pretty excited to kind of kick this off, and yeah, thanks again for inviting me. So let's get going quickly. I think everybody knows this, but let me just repeat kind of very quickly. We know that we have gone multi-chain, right? Very early beginnings. I think we're experimenting with consensus mechanisms, trying different applications, trying different deployments. I think last year we've seen an array of many different applications, many different use cases building in a cross-chain and a multi-chain environment. So that's all looking amazing. It's necessary to continue to scale the ecosystem, to continue evolving with this multi-chain environment. The unfortunate, I think, side effect of all these multi-chain experiences is that everybody is getting fed up with interacting in the multi-chain world, right? From a developer's perspective, deploying in many different software environments is a very complicated process where you have to understand, like, how do you take your smart contracts? How do you take the application, maybe you deployed it on Ethereum, but all of a sudden, you've seen some traction, on Moonbeam and Polkadot. Do you take the same code base? Do you deploy it identically, on the Moonbeam environment? How do you manage all that, and so on and so forth? Users are suffering from multiple fragmentation side effects, right, where some liquidity is left on one chain, some other liquidity is left on another chain. There's multiple versions of wrapped assets, multiple wallets that the users have to interact with and bridge, and so on and so forth. So it's a complete mess so far, and I think one learning that I think we talk about is that in the last cycle, as more and more people get into DeFi, as they actually use the applications, going cross-chain and multi-chain for them, it's actually a very, very painful process along the way. So what do we want to do? High level, I think what we want to do is really optimize for two audiences. A is developers, where as a developer, you should be able to really take the best platform for your needs, make sure you can deploy your application there, and then have robust sort of cross-chain communication support to enable global composability with all the other ecosystems, right? Like, that's the goal. Is it so far-fetched? No, right? Like, every time a Web 2 application is deployed, that's exactly what happens, right? You can take your application, let's say, deployed on AWS, but just because you deployed it there, it doesn't mean it lives in some isolated, lonely environment. People can still send messages to it, and the application can interact with all the users no matter where they are in the world, right? So if you think about it, for the blockchains, it's exactly the same, where as a developer, you should be able to deploy your application somewhere, but having communication with all the other ecosystems is essential. From a user perspective, I think what everybody's craving for is more simplicity, right? Allowing a user to interact with any asset, any application on any chain with one click is kind of fundamentally where we have to get to if we want to continue driving more retail adoption and more users to continue using all these new amazing applications that are coming live. Again, if you look at Web 2, that's a given, right? Where to spin up Zoom or Google Hangouts, you just click, you have an application running, you can invite people to participate with it, that's it. There's no such thing as moving from one cloud service provider to another cloud service provider and sending you packets across. We've been there in the 80s and 90s, and it's not that fun. And so we build the experiences that are way beyond that, and that's what users are craving for in Web3 as well. So to get there, what do we need to actually do? And that's what I want to talk about today, is really think about kind of the new programming model that's starting to emerge with a lot of different applications, which is what I call as a Turing-Complete cross-chain communication, right? Here's what I mean on the high level. The key insight is that traditionally when people think about connecting different blockchains, they made the user do all the work to move their assets from one blockchain to another, which is great, and it kind of works in practice, and there is many use cases where actually need to move the assets to where the application is, which is what I call compute. But the next generation of applications can do much more with this general message passing and kind of Turing-Complete cross-chain communication, is that you can move your compute to where the assets are, right? So meaning that if you have a program that sits on a particular chain, but you see assets that sit somewhere else, let's say on Moonbeam in Polkadot ecosystem, you can actually take a piece of logic, you can move to where the assets are, you can perform various types of computations on those assets, and then update your application state, send the messages back to other chains, and so on and so forth, right? So it's a completely different kind of a paradigm in the programming model where, kind of traditionally, we just stuck with moving assets, and we cannot do that much with it because we can't code arbitrary logic. When you're trying to move compute to where the assets are, you can actually program everything that the user will need to do manually in your compute and in your instructions with the messages that you send, right? So as an example, if the user wanted to move the assets on a particular chain, swap them for something else, and then withdraw them to another chain, traditionally, all of that is then done by the user, doing all the movement and all the hops. But then you can take all that, encode as a message. You can send it along with the assets. You can do the swap, and then instruct the program to send the output of that swap to any other destination chain. So it's a very powerful model where, again, the final point is that you get to automate all the steps that the user had to do manually now in the compute environment with the messages that you send. Does that make sense? All right, awesome. All right, so let me give you a kind of a high-level view of what we're doing with Axeler to kind of facilitate that. On the very high level, the way to think about Axeler is a network of networks that connects very different ecosystems that traditionally speak very different languages, right? So you have Polkadot. It has its own consensus mechanism. You have a lot of parachains. There is a kind of a cross-chain communication protocols and interoperability within it. But then you have many other ecosystems like Ethereum, like Avalanche, like Cosmos, like Bitcoin, that speak very, very different consensus mechanisms, that speak very different language and packet formats. And so Axeler has been designed as a network to efficiently route information and securely deliver it from one of these ecosystems to another, right? At the very core of it, there is a kind of the cross-chain gateway protocols that we're building that responsible for message routing, delivery, and translation layers. And on top of it, the way you actually interact and leverage all these functionalities is still in what we call as a gateway. High-level way to think about a gateway is kind of router in the same way as you have at home a router that receives messages that are originated within your local network and then knows where to forward them and how to relay them to all the other networks, right? So in the same way, the gateway that has been deployed by Axeler on various chains that we're connecting is a router. You can send messages to it from an application, and then those messages will subsequently be routed and executed on any destination chain, and vice versa. It can receive messages from the Axeler network. At the very core of it is Axeler Network, which is a decentralized proof-of-stake network. So it runs a proof-of-stake consensus. It has an open validator set. Anybody can participate, send those messages, read the data, and you have strong security guarantees as of any other proof-of-stake network. All right. So key ingredients of Axeler, well, it's not unfortunately, based on Substrate, but it is based on Tendermint, which, has been the consensus layer that we chose when we were starting out. There are various what we call as finality gadgets. Those are specific objects that allow us to finalize messages on different chains no matter what consensus they have. So whether or not it's proof of stake or proof of work, we can finalize those messages and kind of tune in the parameters appropriately. There's various kind of multi-party cryptography protocols that are involved with it that allows the validators to co-sign messages collectively. And there's a very strong kind of programmability that's baked into the network itself to enable more and more chains to interconnect by just running some commands on the network, right? So, many environments like EVM environments are completely automated. You can run through a series of commands, integrate them, and once they're integrated, they automatically become interconnected with everything else. All right, awesome. This is a high-level kind of view of one of the explorers that's running on top of the Axeler network. So if you want to check it out, go to axelerscan.io. You can see various chains that have been onboarded, including Moonbeam, Polkadot. And so you can route information from any of those chains outside of Polkadot, and then vice versa, right? You can take any information or any token from like Cosmos ecosystem, move it back, to let's say Moonbeam, and then from Moonbeam kind of route it anywhere within the Polkadot ecosystem. And we're making that as simple as possible and having like one-click transactions and so on and so forth. All right. So this is a high-level view of an architecture diagram of what does this kind of a general message passing or Turing-Complete message passing actually looks like. The way to think about it, very, very simplistically, is that on different chains that you want to connect your application with, you would deploy your application-specific logic that would sit on top of the Axeler gateways. So again, remember, Axeler gateway is this router that can send and receive messages. And then on top of this sort of gateway, you put your application-specific logic. And that logic will take messages from a user, route them to the Axeler gateways. Then the Axeler network will finalize, process those messages, execute them on the destination chain. And on destination chain, you can then call your contract to do any other function in return. Right, so as an example, if you want to do kind of a cross-chain swap across different AMMs, then you can do a swap one in a source chain contract. You can return the result of that swap to the gateway, route the asset to the destination chain, and then execute another swap to get the user maybe a different asset that they wish. Right? So all of the kind of user manual steps can now be automated and coded into the logic that simply relays assets, relays messages, executes them on a destination chain, and the user gets a result. So all this complexity is then one-click transaction from a user's front end that they need to execute. So this is a very high level of how some of the interfaces or contracts actually look like. If you want to interact with a gateway, let's say you're interacting with a Solidity gateway, there is a function that says call contract. In this contract, you specify a destination chain. You specify a contract that you actually want to call, so it's an address. And then you specify an arbitrary payload. Right? And this payload is, again, could be a sequence of instructions. It could be a token transfer, and so on and so forth. Now, on top of it, kind of a more general, what we're building is various services that will enable all this one-click functionality. And one of them, which I think is quite important, is an ability for the user to pay gas on the source chain with one-click transaction without having to worry about gas on the destination chain. Right? I think many of you, if you use different chains, it's a very painful experience where maybe you send in like some token, I don't know, let's say USDC from one network to another. You arrive at a different network, and the first thing you have to do is have some gas, right, to actually pay for a transaction to be executed on that destination chain. So in the cross-chain environments where we want to obfuscate this from the users, we don't want to have that friction, right? We don't want to have the users have to have gas on all these chains that these contracts are interacting with. So the way to do this is that there is a certain set of wrapper contracts that sit on top of the gateway that are monitored by different services that allow you to do those kind of cross-chain executions with one transaction paid only on the source chain by the user. Right? So the call effectively has all the same interfaces to do a general message pass and call, except it adds a gas fee that the user can specify, and this gas fee is included then to actually execute the user's message on the destination chain. Okay, does that make sense? All right, awesome. And if the gas is not used, then there's actually a refund, and so the user can get their assets back through a refund. So pretty straightforward and simple. All right. So now what happens on the destination chain? So again, if you trace back the flow of events, you have an application-specific logic. This logic then calls the Axeler gateway. Then the network underneath it will process the message and deliver it to the destination. On the destination contracts, you then need to execute it. Right? So the way to execute it is to instantiate an interface that effectively receives a payload from a specific source chain and a specific address, and then executes with it. Right? There are two models for actually executing it. In some models, you may want to authenticate the address that actually sent the message. So for instance, if you authorize in a cross-chain mint and burn functionality, you only want to authorize it when the associated action has taken place on the other chain, right? So if you burn in tokens on one chain, if you need to mint it on another chain, then you want to prove that the token has been burned correctly on the source chain and only then execute it on the destination chain. So because you don't want to allow arbitrary people to actually execute that function, in that case, you would actually verify that the source address and a source chain came from a contract that you have authorized, and only then you authorize the message. Right? How do you know it came from a specific address? That's where you rely on the Axeler validation layer, right? That always puts the messages and puts them with the correct source and a correct source address, and so you can trust those messages. But from there, you can execute them and validate, the address and so on and so forth. All right. So on top of the network, what we're doing is building various services to make those cross-chain interactions as simple for the users and application developers as possible. So the first one that I already talked about is this gas service that allows the user to pay gas on the source chain in one transaction and not have to worry about gas on the intermediary chains or destination chain where the messages are executed. The second layer of services that we're building, which is really fundamental, is an ability to monitor the state of these cross-chain interactions, right? In the same way as you're monitoring what is the state of a transaction when you go to an Explorer for a Moonbeam, and you know exactly, has this transaction been executed? Has it been reverted? What is the state of the reversion? And so on and so forth. When you're doing cross-chain interactions, you have to give the same level of visibility to the developers and the users, right? So we're building that out. You can look at Axeler Scan. You can use the API service that we're building to understand, has the gas been paid? Has the token been approved? On which chain it's currently at? Has it been executed? Yes or no. And if it has not been executed, like what are the errors and how do you recover from them, and so on and so forth. And then another kind of example service that we're building is this ability to relay and recover transactions. And so this is actually a very core property of the Axeler network, is that by itself, it provides you with the same set of safety and liveness guarantees as any other proof-of-stake network, which is the validation layer itself. Now, relaying between the Axeler network and all the other interconnected network is completely permissionless process. And that's a core feature and a core function of a secure and robust interchain communication, is where you're not dependent on a particular service provider or a network in order to relay messages, right? So we can run a relayer, you can run a relayer, your user can relay transactions themselves, and so there is no dependency on the execution of them on any particular provider or any particular network. If one of the network goes down, then you can still relay messages from all the other networks, right? If one of the relayer services goes down, you can continue relaying messages, without any dependencies. It's a permissionless, process. Users can self-recover, and so that's really, 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 really powerful. Again, in the same way as you can do those functionalities on a single chain, you can do them cross-chain. All right. Example use cases, I think, range really from, cross-chain NFT, DeFi. We're seeing an array of very interesting applications like Prime that I think, we talked about today early on the panel, where, they're deploying their contracts on a single chain on the Moonbeam, and then they have various satellite contracts that are, using Axeler to communicate cross-chain. We're seeing various NFTs, kind of a payments, and so on and so forth being built out. And yeah, I think the future is really, really bright for this kind of a unifying all these different ecosystems, making it as chain agnostic as possible for the users to interact with all of these different environments. So on that, I'll leave you with a couple of QR codes you can scan. You can sign up for our social channels like Discord. Ask any questions. There's a developer channel there. You can check out docs of how to actually get started to build a cross-chain application. There are links to various explorers and various other sources of information you can find. So, and I guess the final message that I want to leave you with is to really think about how do you build simplicity into your code, right? Again, I think we're so used to thinking about usefulness and functionality and advanced mechanics and tokenomics and so on and so forth, that I think we just forgot how to make simple tools for DeFi for average users. And I strongly encourage you, as you build in this bear market for the next wave of retail users to come, is to think about how do you build simpler experiences. And I think things like general message passing, Turing-Complete cross-chain communication is a step that will enable you to do that. So on that, thank you so much. And I don't know if I have any time for questions, but if not, then I'm going to be around, hang out for a bit, so you can find me and ask any questions.